Hi everyone, welcome to Suthra Online. This is Narsimha. Today in this session I am going to explain about electric circuits. So what is mean by electric circuit? Electric circuit is nothing but a continuous and closed path an electric current is called electric circuit. A continuous and closed path of an electric current is called electric circuit. So how we can make the electric circuit, which materials required to make the electric circuit, we'll see right now. So first we need a source of electricity, right? Come to second one, conducting wires. We need conducting wires, that means copper wires, right? Here next to electric device is nothing but a electric bulb. Next, these three are connected with the help of switch. So now I am going to make the electric circuit. See here, first initially I am taking here source of electricity, that is nothing but cell. So I am going to attach the conducting wires to the cell, and I am taking here one electric bulb. So this is nothing but filament, right? This is nothing but switch. Generally children are playing, they can take one cell, conducting wires and a bulb. The conducting wires attached to the cell, the bulb will glow. If conducting wires not attached to the cell, bulb does not glow. That means if I switch on, means the current will flow through the current. If then flow through current will flow through the circuit, means what happens, bulb will glow. If I switch off, means the circuit will be open. When the circuit will be open, means there is no current in the circuit. So generally this is the about electric circuit. Generally we can use sometimes only single wire to connect the electric devices or electric bulbs. Sometimes we can use many wires or many paths to conduct the electric devices. So based upon this nature, electric circuits are divided into two types. So first one is series circuit or series connection. Come to second one, parallel circuit or parallel connection. Now we will discuss about series circuit or series connection. Let's see. Series circuit or series connection, right? Or series connection. First point, in this series connection, all the electric components are connected in a single path. All the electric components are connected in single path. So all electric components or electric devices or electric bulbs components connected in single path. Come to second point. What is the second point? The magnitude of electric current same throughout the circuit. So same electric current pass through each resistor. Each resistor means electric component. Next, come to third point. potential difference across each resistor will be different. Potential difference across each resistor will be same. Resistor not same, is different. Sorry. So potential difference across each resistor will be different, right? Now I am going to take that how it will be that series connection. I am taking here one wire. So that wire is connected to the source of battery. This is nothing but battery. So if you can take two cells, you can attach, means that is become battery here. So right, I am going to arrange the switch. The electric bulbs are connected in a single pair. Right, I am taking here 4 bulbs. These all the 4 bulbs are connected in a single path. So if I switch on, means what happens, the current comes out from the battery, which is passed through each resistor will be same, but this potential of the battery across each resistor will be different. So V1, V2 and V3 and V4, right? But here these electric bulbs are having resistances. I am going to take R1, R2, R3 and R4. So this is the general circuit for a series connection. This is the general diagram. Now these 4 bulbs are having different resistances, R1, R2 and R3. Now I am going to find the equivalent resistance in the circuit. So for that purpose I am going to take 3 resistors. Right, I am taking here 3 resistors, R1, R2, R3. So these 3 resistors are connected in a single path, right? So right, this is the battery, plus minus. Right, current is coming from the battery, right? The magnitude of current flow through each resistor will be same, that each resistor resistance is R1, R2, R3, right? Now the potential of the battery provides across each resistor, that potential is V1, V2 and V3, means the potential of the battery provides across each resistor, that potential difference will be different. Now the total potential in the circuit that is V is equal to V1 plus V2 plus V3. This total potential is equal to the sum of these 3 potentials, that is V is equal to V1 plus V2 plus V3. Now I am going to consider as equation 1. Now if I apply the Ohm's law, what is the Ohm's law? V is equal to IR, Ohm's law. Now I am going to apply Ohm's law across each resistor, then I am going to find the potential across each resistor. So if I apply Ohm's law across resistor V1, across resistor R1, then what will get here? V1 is equal to IR1 and also V2 is equal to IR2, right? Next come to V3. So V3 is equal to IR3. Now these 3 values you can substitute in equation 1. Then that is, I am going to write equation 1, that is V1, V is equal to V1 plus V2 plus V3, right? So if I substitute V1, V2, V3 values in equation 1, then you will get here IR is equal to IR1 plus IR2 plus IR3. So IR is equal to, right side I am going to take I common, right? R1 plus R2 plus R3. So both side I am going to cut I, then you will get R is equal to R1 plus R2 plus R3. So this is nothing but where R R is nothing but equivalent resistance in the circuit. Equivalent resistance means all the resistors can be replaced by this equivalent resistance. All the resistors can be replaced by this equivalent resistance. Now that is R equal to R1 plus R2 plus R3. When I am taken 3 resistors, then you will get a equivalent resistance, that is R1 plus R2 plus R2. If I take 2 resistors, then what will get? If I take 2 resistors, then equivalent resistance is equal to R1 plus R2. If I take the number of resistors, then what you will get here? R is equal to R1 plus R2 plus R3 plus so on Rn. Right? So this is the equivalent resistance when the resistors are, number of resistors are connected in the series. If and one more important point, this equivalent resistance is more than greatest resistance in the circuit. That means what here? So see here, I am taking, students listen, I am taking here R1 is equal to 2 ohms, R2 is equal to 3 ohms, R3 is equal to 5 ohms, right? Now I am going to find the equivalent resistance, then what you will get, see here. So R equivalent is equal to 2 plus 3 plus 5, then equivalent resistance will get 10 ohms. 10 ohms. So in these 3 resistances, which one is greater than, which one is more value? 5 ohms is a more value. Then equivalent resistance is more than greatest resistance in the circuit. That means here R is greater than R3. So this is just generally, and one more important point where we can see this series connection, this type of series connection means this type of connection in our day-to-day life. Generally we can see this type of connection, decoration bulbs. So decoration bulbs are arranged while festivals times in streets, on buildings, in houses. So once again recap about series connection. First point is all the electric components are connected in single path. Come to second point, the magnitude of electric current across each resistance will be same. Next, come to third point, the potential difference across each resistor will be different. And come to fourth point, equivalent resistance in the circuit value is more than greatest resistance in the circuit. So this is about series connection. For more videos, for more information, please download the Suthra online app and follow my YouTube channel, that is HNS Physics. Please subscribe my channel. Thank you for everyone.